Server-side technologies are here, and now often there are banners. Like you remember, you have an Apache banner here telling you information about what version of mod gzip, what version of mod auth pass-through they use, and so on. Often the banners by default tell you the version of everything. I don't know why people do this, but they do, and that's of course information you don't really want to tell an attacker. You might be using an older vulnerable version of something. All right. And so banner grabbing grabs this stuff, and it also grabs other information, general information about the page. Then you can use HTTP fingerprinting. There are tools that will scan a website just to detect what technology is being used to make that website. So here it's determining it's using Apache and Microsoft IIS and so on. Wapalyzer is a browser extension you can put on, and it will do the same thing. Just load a website, and it will tell you all the technologies used there, which these days are often JavaScript-based technologies like Angular and Bootstrap and so on. All right, then you can tell what's going on from the file extension. ASP is Microsoft's active server pages. This is Java server pages. Here's ColdFusion, another web technology. PHP, one I use all the time because it's free. WebSphere, Perl, Python, Microsoft compiled libraries, and Lotus Domino. There are common extensions that will detect common technologies. Error messages are very helpful. Here's one, I think, is this one from the book? Yeah, that's one from the book. You see an error, and you have an ASP page with an error. You'll just get a characteristic error page with this red font, so you can tell that it's at Microsoft. Here's a generic error message created that just says the page cannot be found. This kind of message usually doesn't tell you much of anything, but this one does identify it as IIS. In general, it's considered poor web design to ever let this kind of error page go out. You should have a custom error page that's friendly that says, we had an error, please call our help desk or something. These generic pages are a bad user experience, in addition to often revealing information they shouldn't be revealing. And so different DILs can in principle lead to different error mappings. You can, there's file extension mappings for different DILs. So you might see error messages that tell you different things about libraries you couldn't find. And yeah, probably opening that door is always a mistake. I don't know what's going on. All right. All right, open text is another one where they have these comma-separated things at the end of the URL. That's another strange format that people use for this particular content management platform. And you can tell from directory names. There's Java directory name servlet, Silverstream, if that thing is still in use, ColdFusion, Oracle, Rails, Ruby on Rails. There will be some sites like that and so on. Here's Apple Web Objects. So the directory names and the file name extensions are pretty predictable, and they tell you what technology is being used. Then the session tokens, the cookie that identifies who you are. Java uses JSession ID, Microsoft uses ASP session ID or ASP.NET session ID, and PHP session ID for PHP and ColdFusion. So, just looking at the cookies in the request will tell you what technology is in use also. And then there are a lot of third-party components. A lot of people use standard things to handle shopping and login and message boards. They just plug in standard things, and then they may contain known vulnerabilities. One I hear a lot about is Magento. Magento is some kind of shopping extension that a lot of websites use, and it keeps having serious vulnerabilities. I've seen it in the news for years. All right. And so you find all the places for user input, all the ways you feed it in. Then you look at the query string format, find all the channels that allow user controllable or third-party data into the app. Then you look at the banner to find out what servers are in use, and most modern websites use many different server processes to build the website. You try to fingerprint them and research them for vulnerabilities. Then look at interesting file extensions with clues about technologies in use. These are all ways to find out what technologies are in use. HTTP print is a tool to do this that hasn't been updated in a long time, mentioned in your book, but you can also do it with Nmap, Netcraft, or Shodan, or Wapalyzer, many other tools to identify what technologies are in use on a website. And so then look at your session tokens, lists of common technologies, and unusual cookie names and so on. These will all give you clues what kind of technology is being used on the website. And so here you have a request to a calendar.jsp, which is Java server pages. And then if you look at the parameters, you'll see order by name. Now that is a SQL command, order by. So that suggests that some of this data is used directly in a SQL statement, and that suggests you might get away with SQL injection, or you might be able to at least change this and so on. So if you understand the technologies, looking at the structure gives you a clue what attacks might work. All right, and here we go to active server page. This is a Microsoft server. And now we have template. Here's the name of the template, a template file. So that seems to suggest this appears to be a real file name. So you might be able to do directory traversal and go to different files here. There's something called edit equals false. So maybe if you change edit to true, something interesting will happen. There's a version number here. Version is 2.31. Well, changing that, you might find some other functionality or something interesting. So that's what I mean. Just by, guessing what's happening guides you into making intelligent attacks. Here's a post going to a feedback form, and down here is a from and to and subject. These are email fields. So you're using PHP, and we got user controllable content in these fields. These are the standard fields of an email, and there's a bunch of attacks on that. For example, if you can inject carriage returns or line feeds in here, you can send extra emails. That's a content splitting attack, and we'll do some of those in the projects. You'll see them. All right. And putting those guesses into BERT for testing guesses. Yeah, that's the easiest thing to do. This would give you a clue. Yes, you would modify those things by using BERT. You'd record this request and replay it, and then try modifying some of these fields. All right, and so here we got this thing where you have a RESTful URL, and so this probably means these are 117 and view and media are probably parameters. So that's a thing to know. So one of these is view, that's an action. So you might change that to edit or add and so on. And this ID number, probably you can change this number and reach other pages or something. So, that's the sort of thing you do. All right, so then you try to extrapolate the behavior. Once programmers write something, they just reuse the code and they think the same way. So if you find if your SQL injection is being filtered out, you can try injecting special characters in something else, like a username or a file name. It's probably just using one standard filter function, and you can guess how it works. This also works for web application firewalls. I saw a good talk from Joe McRae years ago. There's only a few brands of web application firewalls, and he found attacks that will identify which one they're using. And after he knows which one you're using, then he knows what will punch through it. So, all right. If the app obfuscates data, where it scrambles it or encrypts it or something, try to find some other place where you can enter an obfuscated string and get the original. This is very common in your technique. When you have encrypted stuff, you can often find the encryption code and run it else, or find the encryption agent and use it. And there's an example we'll talk about later in the course where a bank had encrypted data, but there was another part where that same data was used to encrypt a chat name that was under your control. So you could use that other part to design something that would attack it and the other part. Or you can, for simple obfuscation schemes that are not as good as encryption, you can just feed in systematically varying values. I used this to find a flaw in the Stitcher app years ago. Stitcher app is a music playing app, and they encrypted your password with a modified Caesar cipher. And I was able to tell that by just using a short password and putting in like A, B, C, and there was a pattern in the output. So if they're doing something simple, you can detect it. All right, errors might be handled properly and give you little information, but others might crash and return verbose information, so your error handling might be useful hacking information. There are also Google dorks. Once you find a vulnerable website, you can find ways to do it. So here's one, like a Microsoft .NET framework page entitled illegal. These will be some kind of error messages for .NET. Here's PHP error messages. Elma, this was pretty interesting. Elma is a server product that shows website errors. And I read about this a few years ago, and I found open source, I think, on Toyota that would just have full URLs. And you can use this to hack into individual people's accounts. If you have an error log that you can see, you can then go in like a chat or Twitter and send them a link to click. And the link will go to that site and have like a bad character in the URL, so it will create an error. And if they're logged in, the error log will have their cookie, and now you can get in their account. So Error logs are often vulnerable. And here's another one, MySQL error with query. These things are called Google dorks, special Google searches that find vulnerable pages. And these are commonly used by the sort of troublemaking hackers. Script kiddies will find a vulnerability, then they'll use a Google dork to find like 1,000 pages. Then they'll write a script and deface those 1,000 pages. This is not really something a professional pen tester would do, but it's a nuisance on the internet. People come in and hack many websites. They have competitive forums where they just try to hack the most websites to win a prize. And here I found at Walmart, I just put an apostrophe or a quote at the end to try to look for SQL injection, and I got blam, a whole bunch of interesting error messages explaining all kinds of far more information than they should have told me about the Walmart website. All right, and so you look for consistent frameworks, look for things that might be bolted on later, like CAPTCHAs, usage tracking. There's been quite a few news articles about faulty two-factor authentication methods that people put on. Things that look different, have different comments, were things that were added on later or built in from another company, and that's often a place where you'll find errors. The most common place to find errors is when one system is translated to another system. Yeah, that's good. Someone's posted on a Google Dork database there. Yeah, there's a lot of them. All right, so check for client-side validation, SQL injection on the database side. If you find a name of a file anywhere, then you can try path traversal and perhaps stored cross-site scripting in the name. If they display any user-supplied data, you can try to put tags in it, and that's cross-site scripting. If there are dynamic redirects, like when it's done, the next page is somewhere you can control it, you can often redirect it and cause pages to go to an unexpected next page. And we'll do all these things in the project. Social networking features will often have, you can find usernames there. Logins will often let you enumerate username because they give you a different error message if the username is wrong than if the password is wrong. So you can crack those two things separately, and that makes it much easier to break in. Multi-stage logins often have flaws. You have to do step 1, step 2, step 3, but somehow I can skip to step 3 without satisfying step 2. And of course, the session state is a token, and you can do a lot of things wrong with the token. You can handle it poorly, so I can steal it. For example, transmitting it without encryption, or it can be predictable somehow, so I can forge somebody else's token. So these are your access controls for horizontal and vertical privilege escalation. Horizontal escalation is when you go to impersonate another user. Vertical escalation is when you become administrator. And there's often impersonation functions that let the administrator log in, use a user's account as a user, and you can sometimes defeat that. We talked about clear text communications, let you steal things. If you have links to another website, you might have the referrer header from this site go there, but the referrer header will put in the entire URL, so there might be sensitive parameters in the URL that are then exposed to a different site. All right, and all right, good, we're nearly done with this long list of things that can go wrong. Your error messages can leak information. If you have email pages, I might be able to send extra emails you didn't want, or even commands. If you have native code components like DIL files, then they might have the typical binary vulnerabilities like buffer overflows. And this is really a big one. One of the OWASP top 10 is that you use third-party components with known vulnerabilities. This is why everybody's talking about supply chain problems now. Your libraries might be vulnerable. And how do you really know which library versions are used in your product? And are they all properly updated? And of course, if you have figured out the web server, then there'll be the common vulnerabilities of that web server. So here's an example. The auth contains authentication functions, so you might find session handling and access control problems there. There's a core site stats someplace that has parameters. Yeah, up here. Here's a bunch of parameters, page ID and display and so on, and all those parameters might be ways to attack. One of them contains a path, so you might be able to do traversal. There's a home here. This is where the authenticated user content is, so you might be able to move into another user's account. If you find a name there, you can change to another name or something. Icons and images are static content. Those are just loading files. Normally, you won't be able to do anything with that. And pub has RESTful resources here, pub, media, user, 11, 13, 18. So the only thing appealing there is these numbers seem to be pretty low and in order, so changing it to other numbers, you might find things that you're not supposed to see. And here's online shopping. which has a whole bunch of objects handled similarly, so you can see if you find any way to do something you shouldn't be able to do there. And we'll do a lot of these in the project in more detail, so I won't do any more Kahoots today. So that's it for the lecture. Let me stop this.